Okay, so I think we should start. In this tutorial, we will go through the questions about the PKI, public key constructor, SSL, and the versatile attack. So before the tutorial, let's first clarify some basic concepts of PKI. So actually, PKI uses asymmetric keys to do the encryption and decryption. So that means unlike the previously crypto algorithms, in the encryption part and the decryption part, we use a different key. For example, in the encryption part, we can use a public key. And in the decryption part, we can use a private key. And of course, we can use the private key to do the encryption and use a public key to do the decryption. And public key means that everybody gets access to these keys, so it's not protected. And for the private key, obviously, only the owner has access to this key. Okay? So actually, how do we use it? And consider the scenario that Bob and Alice want to communicate with each other. So that we have discussed here. There are two scenarios. The first is that Alice use public key to do the encryption, and Bob use private key to do the decryption. And besides, there is another scenario. Alice here use a private key to do the encryption, and Bob use a public key. Okay, and actually here the public key and the public key and the private key here actually is a pair, which means if you have a public key A and there is a public key private key prime A prime, and for another, you can only use the public key A to do encryption and use A prime to do decryption. You cannot use the public key A to do the encryption and use P prime to do the decryption, which means they are paired, right? Okay, so here, after we illustrate these scenarios, let's first evaluate whether it's safe or not. So how do we evaluate? Actually, we will evaluate from two metrics. The first one is confidentiality, and the second one is authenticity. And I think you guys have already knows these concepts in the first tutorial. So let's first say the confidentiality. So here, for the first scenarios, A, Alice use a public key to do the encryption, and B use a private key to do the decryption. Okay? So here, how about the confidentiality? If there is a choice, can Chinese get the plan test of the ciphertext? No, of course no, because only if you own a private key, you can get the capability to do the decryption and get the plan test, right? So even Chinese can somehow eavesdrop the ciphertext map the Alice. Chinese still cannot get the plan test. So the confidentiality for the first scenario is guaranteed. How about the second one? Because here, in the decryption part, Bob actually use a public key to do the decryption, which means everybody can get access to the plain text because this is a public key and we all have the access to these keys. So the confidentiality is not protected, right? So the second is authenticity. So for the first one, how about first Alice use a public key to do the encryption and generate the ciphertext. But how does Alice knows that this public key is a pair of the private key, of this private key? What if Chinese just send the public key to Alice? And okay, so let's consider this is B. This is B prime. And Chinese also have the private key. See. What if Alice just mislead Alice to believe that the public key B O here has is public key C? So in this case, you do not know, right? Because you cannot protect the authenticity in the first place. Alice will not know the authenticity of source of this public key. So the authenticity is not guaranteed. But how about this one? When Alice actually uses a private key to do the encryption, she will not be misled because the private key, because only the Alice has access to a private key. So even Chinese here send an Alice Chinese private key, say from here, Alice will not believe because it doesn't make any sense, right? We can I have a private key. Why do I use your private key to do the encryption? So the authenticity here is intact, is protected. So as we can see here, both scenarios have their own limitations, but we want to have optimal or perfect strategy that can guarantee both confidentiality and the authenticity. And that's the reason we have the concept of PKI, public key infrastructure. So how do we do it? We just involve a trusted third party. We call it CA, certificate authenticity. So what does this CA means? Or what does this CA do? Actually, as we can say in the first scenario, we will find that because the Alice do not know or cannot tell whether this public key is from Bob here, right? And that's why the authenticity cannot be guaranteed. So how about we have a trusted third party, and any information from this third party is trusted. In this case, we can just let this third party, this trusted third party, to distribute the public key. And in this case, since we have a trusted third party, and all the information from this third party can be trusted, so Alice can know that the public key she got in the first place is actually a pair of Bob's private key, right? But how does this CA send the message to Alice and tell Alice this public key is actually Bob's private key? So here, CA will send a certificate. CA will send a certificate to Alice here. So how does this certificate look like? Actually, this certificate will include 4 information. The first one is entity name. Here, entity name is Bob. And valid period. Let's consider it's a year. And then it will include the public key. Here, because we want the Alice to know that what kind of public key Bob has, so the public key here is Bob's public key. And the fourth part is a signature, because CA here have to sign the signature, and then Alice will know it's actually from the CA, not from Chinese. Okay? But how do we get this signature? First, we can say that we have these 3 informations. So the first part is due to the hash. You can use any hash information you have. We will say later in the real world certificate. You can use a sharp or any kind of hash. And then what you do to get this certificate? You will use CA's private key. The CA's private key will be used to do the encryption. And then this whole package will be considered as a signature and then transferred to the Alice. And in this case, Alice can know that the public key he used to do the encryption is actually a pair of Bob's private key. And then, since we use the PKI, we can find that the confidentiality is guaranteed. Also, the authenticity is also empty, right? So let's see the first question. In this question, it says that there is a certificate and it will include 4 parts: name of entity, public key, period, and signature. So the first question is for the second part, for the public key, whose public key is it? Of course, it's Bob's public key, right? In our scenario, which means it's entity's name. So for the second one, the signature is computed from a key and together with a message N. So whose key is it? And we can say previously, actually the CA will use its own private key to do the encryption, or you can say it will use a private key to do the signature. So this key is actually from the CA. And also, what I included in this message, actually it will include 3 parts: the entity name, public key, and period. All of these information are included in the signature or in the certificate. Any question about this one? So for the second part, what is a self-signed certificate? Who typically use it? Actually, in self-signed signature means that here we use the CA to generate a certificate, right? But sometimes we can consider ourselves as a CA. And why do we use that? Why do we use a self-signed certificate? Since we have already got some trusted third party. And actually, there are 2 reasons. The first reason is that since maybe, okay, so for our project, for example, for your CTFD project or for CTFD platform, you will say that we use our own self-signed signature here. There are 2 reasons. First is that if we want to get a certificate from a third party, that will cost us over 1,000 Singapore dollars. And it's not worth it for the earlier developers, for example, for some course assignments. And second part is that when you really want to get a certificate from a third party, it will take a lot of time and efforts. You have to communicate with the third party and get a genuine certificate. And that's the reason in this course or in some earlier stage projects, we use a self-signed signatures instead of the signatures or certificates from the third party. Okay. So for the third one, find out the list of certificates stored in your favorite OS. Actually, this is a Windows machine, so let's just figure out how do we get a certificate from this machine. Okay. So there is a settings, and when you create this, you can just search the certificate. Manage user certificate. Here you will find a lot of information. It's just consider we create this one. And there are a lot of certificates you will use in your daily life. And we will see a very important example. For example, for your assignment for this platform. Actually, it says that there is a certificate error. That's because we generate the certificate by ourselves. Still recording that. So in this case, we can find that here to the fourth question. Actually, in the first question, the scenario is that nowadays we have a school and there is a local network infrastructure or configuration in this school. The scenario is that we have a lot of machines in this school Let's consider this was used by some students, and this student is Alice. Okay. And when these students want to go surfing on the internet, they have to go out, right? For example, if they want to. If they want to go to the Google, they have to send the network package to the Google website, right? Now here, in this particular scenarios, school will set a gateway here to monitor all the information between the machines in the school and the outside website. And every machine have to send the network packages outside through this gateway. There is if all the network packages have to go through the gateway. Yeah. And the first question is, okay, the first question is that suppose the Alice wants to send the applications to this website. Does M here, the monitor M here, can access the pen test? Actually, the answer is no, of course. Because here you can see that it actually uses HTTPS here, and S means SSL. I think you have already got this concept in your lecture. So in this case, Alice will firstly create the pen test, right? And then even here, the gateway monitor can install or load the network package still and cannot get the pen test because it's encrypted data. Okay. So the second question is that the school insists that all the network traffic must be inspected. I know how do they do it. They just drop off all the encrypted network packet, which means if this monitor M here receives any HTTPS network packages, it will just directly drop it off. Okay, which means if this is a DNS website, if you want to send a message to it, it doesn't work. Because here, your message will be dropped off, okay? And you can never access this DNS website. And actually, I don't know whether you notice this or not. Most of the websites you log in or delete outside nowadays, or use this HTTPS protocol. And that's because their websites or their companies want to make sure that your data will not be known by others, and they want to guarantee the confidentiality of the messages or the network packages. So it's actually not practical and feasible in the real life scenarios. Okay. And for the third question. Actually, the school noticed that this is not correct. This is not the correct or practical strategies. So they want to make sure that the students, making students' browsers forward to any session keys. So what does this mean? Here, we can know that if this Alice want to send a passage out, it will include the encrypted message, right? And the message will go to the happytools.com, this website. So instead, besides this message, the school want the Alice not only send out the message, but also the session key. So in this case, even the monitor only can receive the encrypted data because it actually get access of this session key. He can just decrypt it by himself, and he can demonstrate or get the plain text or the network packets. But is this practical or not? Actually, it's not. Why? Because here, I mean, in a traditional design, originally, browsers only send out the message, right? They do not send the session keys to the outside world. But if you really want the browsers to send all the information, including both messages and session keys, you have to modify the browsers, right? Right? Is that correct? That's correct, right? But here, let's just consider in these scenarios, in these classrooms, we use different machines. We have Windows machine, we have Linux machine, we have MacBook, we have iPad, we have iPhone, right? We have different machines. And for different machines, we use different browsers. We use Safari, we use Firefox, we use Microsoft Edge, we use Chrome, right? And besides, each browser has different versions and they have different update. And if you really want to implement this in your school, you have to change or modify all of these browsers. And that's not possible. Besides, change the browsers is not that easy. You have to be very familiar with the architecture of Chrome's or these websites. So of all these browsers, so it's still impossible for the real world implementation. Any question about this part?
They actually chooses the Zoom mechanism. Does it mean that any students, if they intersect message, will be able to post
Oh yes, that's another question. That's another limitation, yes. Because if I can actually monitor the network packages in the school, because every package do not only hold the messages but also the session key, right? If I'm a student, I'm a child. If Alice sends out the message, if I can get this message or get this packet, I can just do the decryption by myself because I have both messages and the session key. Yes, that's okay. So let's say the fourth spectrum. So here is the school just totally changes their strategies. They want to use M here as the man in the middle. So previously, how does A communicate with Happy-Tools, this website? As we know previously, right? Because they want to communicate with each other, and Alice wants to make sure the public key is actually from this website. So this website will send a certificate to Alice. And this certificate, we just use Bob here to represent the Happy-Tools website. Okay, so similarly, this certificate will include 4 parts. The first part is entity's name. Here, the entity's name is Bob. And period is, let's say, a year. Okay, and then we have a public key. And also the public key is Bob's public key. And the last part is your signature. Okay? So after Alice gets these signatures, they will finish the handshake in the TCP communications. Do you know the handshake and this kind of operations in the network communications? Okay, so actually this is the TCP protocol. So generally speaking, there are 2 steps. The first step is that let's suppose that there is Alice and there is Bob, right? They want to communicate with each other. The first step is, actually there are 3 steps, but just simply speaking, there are 2 steps. So the first step is Alice and Bob will handshake. They will, they want to know you are Alice and you are Bob. And after they confirm each other's identities, they will handshake. And then they will generate a session key to do the encryption. Okay? So which means that this is the first part. You can consider this as this is the first part. In this part, they will handshake. And after that, any informations and here will use a session key. To do the encryption, right? And this session key is generated in the handshake steps. And basically there are 2 keys. The first key is K, and the second part is T. And key here is to guarantee the confidentiality. It's like some encryption. And T here is actually MAC value.
So just to clarify, both K and T are symmetric in this case.
Yes. And the T here is actually MAC, and it will guarantee the integrity here. Okay. So this is we consider this as a session key. Okay, and during the communications, they will use this session key to do the encryption and decryption. Okay, so this is basically the traditional strategy. This is how the Alice and the Bob communicate with each other in the first place. So here, how does this will change the scenario so they can actually eavesdrop the packets?
What is the word above Mac?
What?
What's the word above Mac?
Session
What
key.
session? SE session.
Yes, session.
Okay, thanks.
Okay. So they will actually use a manage the legal concept here. When Alice communing with M here, 0. They also want Alice to handshake M. And in this case, because A actually communicate with B, so M will be like a manage the attack. It will use B as the entity name and the period. But instead of use M, this public key here, actually M use M's public key. In this scenario, in this particular question, this is the key. Okay. So then they will also get a signature, and this is how A and M communicate with each other. In this case, they will also generate a session key. Let's consider this as a P1 and a P1. Okay? And besides, after M gets the messages, the encrypted messages from A, because here they actually handshakes and they share the same P1 and T1. M has a capability to decrypt the messages sent by Alice. And then how does this M do? What does this M do? This M will generate new channels to handshake with B here. But instead of using M's public key, it will use S public key. And also, after they generate the session keys, they will use T2 and K2 here. So this is actually a manage the middle scenario.
Possible, isn't the certificate supposed to be verified by C?
Yes, because here, right? M here actually use a self-signed certificate, we do not like what we do in our CTFT platform. We do not use the CACE platform. We use
On ACE side, you will be able to actually see the results.
yes. And actually you will see the certificate error in your URL of your browser, but that's fine. Okay. MCare will generate a self-signed certificate. Okay. So the basically the scenario is that if A want to send a message to M here, first it will use the setting keys M and A shares to do the encryption. So let's say this is a plain text. First, it will use session keys, K1 and T1 to do the encryption. And then it will be transferred to M here. And since M also has a K1 and T1, it can do the decryption. Okay? And then what does this M do? It will repeat the encryption part that is still here, but instead it uses K1 or K2 and T2 and gets a ciphertext save time and send this ciphertext to HackingTools website. Because M and HackingTools share the same K2 and T2. That is HackingTools here can see the plain text of the M, and this is the whole process of the man in the middle strategy. Any question about this part? Okay. Now let's go to the last question. It's a birthday attack questions. So actually it's a hash creation. So previously we use this equation, if I record this correctly, we use this equation to calculate the possibilities that two hash values will collect, right? But here, it uses different equations. Okay, it's also a hash creation problem. But actually, why you are given a different equations from your class, from the lecture? Which one is correct? Actually, they are all correct. Why? Because here, how do we calculate the possibilities? We actually use a distribution algorithm to calculate. And in the first equations, it actually uses evening distribution. You consider all the hash values are evenly distributed. And this is how they calculate the possibilities. And for the second one, we do not know how do they get it, but obviously it just consider this question or these problem scenarios as different distributions. And that's why you will be given a new equations. And by the way, in your exams or in your midterm or finals, if you meet this kind of questions, please use the equations given in the problems, in the questions. Do not use this one, because sometimes it doesn't work. Okay? And the rest are the same. Actually, this 2.7 can be can be represented by the E here, because the E actually approximately equals to 2.7. Okay. So as we can see in these scenarios, K is actually the number of students. Here we have 158 students. And what are these M and N do? Actually, we will generate N messages, and each message will include N bits, right? So, N equals to N equals to. Here we have. Okay, because each message will include student ID, and each student ID include 16 bits sequence, right? So the N equals to 16. Okay. So now we know the key and the N here.
Okay.
So for the first question, what's the possibility that at least one student benefits from your attempted school deal? Okay, school deal. Actually, this student will randomly choose 32 pieces of papers, and that's the reason why M here equals to 32. Okay. Now we have known all the values of variables in this equation, so we can just put them into these equations and get the possibilities. Okay. And the answer is. Answer is 0.06, and that's the possibility that at least one student will benefit from this. Okay. So the second question is how many pieces of papers do you need to submit? So that the possibility is more than 0.5. Also, we will use the same equations, but here we do not know n. Still, the key and the n are not changing because we still have 2 powers of 5 students and 2 powers of 16. We have a 16 bits student ID, so these 2 values are not changing. So what we need to do next is to take them into the equations and calculate the n here. It's equations. So the answer is 512, which means you have to at least generate over 500 messages, so that the possibility of one student getting benefit from your deal is more than 0.5. Okay, so I think this is the same. This is a similar question as the previous tutorials. So it's not that. Okay, so that will be all for today's tutorials.